Okay guys, welcome to the week 9 walkthrough of trigonometry. So I'm just going to do a couple of things. I'm going to start with hopefully what you know. I'm going to relate it to some graphs which you may not be familiar with, and then bring it back around to the answer again, just so there's a little bit of extra, so I don't know how this was taught to you in the first place, a little bit of extra understanding which will help you in the long run when we do trigonometric graphs if you haven't already seen them. Okay, so I'm actually going to start with this question down here. So the first thing is you might be used to is the labelling procedure for trigonometry. So if you've got a right angled triangle, the length which is opposite the angle, so I take a line and draw one opposite, that will be labelled the opposite. The longest from Pythagoras we know is the hypotenuse, and then the one between the right angle and the angle itself is called the adjacent length. Okay, and then of course from there you may therefore also be familiar with this idea of SOHCAHTOA, which essentially lists off the relationships and the trigonometric function which links them together. Okay, so for instance, if we took this first block of 3 here, this tells us there's a relationship between the opposite length and the hypotenuse, and the function, and I'll come back to that word and why I'm using that word in a minute, is sine. Okay, so let's just go through the process of what's actually happening. So let's say I want to find this angle here. So I look at the triangle and I have the adjacent and I have the hypotenuse. Okay, so perhaps you've been taught to come over here, find the relationship, which is cos. Okay, and then you might be able to make a statement in fact and say that the cosine or cos of the angle x is equal to your adjacent, so it's in order, adjacent divided by hypotenuse. So 13/21. What does this mean? Okay, so essentially what we have is up here is, again you might not be familiar, but this is the cosine graph. Okay, so there's actually a graph which graphs all the relationships between the adjacent and the hypotenuse of any triangle, and it gives you the angle associated with that relationship. Okay, now you might ask, well, how does that work? Because there's infinitely many triangles. Well, there aren't, if you take into account all the triangles that can be created from the same angle. So for instance, if I kept this angle x here, whatever it is, there are infinitely many triangles I could draw that would still have that same angle there, and they'd all be what we call similar. Okay, so for instance, if I extended out this line here and this line here, so now this length in total was, let's say, 42, and this length here was 26, i.e. I've increased the length of this triangle by a scale factor of 2, then I would still write the statement cos x to find the angle would be now 26/42. But of course that's the same as 13/21. So in fact, by drawing this one triangle, we've now taken into account the answers for this one angle for thousands and thousands, as I said, for infinitely many triangles. So that's great. So now we have situations where I only need to take account of what is the relationship between an adjacent and hypotenuse for this particular angle, and does it simplify down to this particular number here, and if it does, I know what that angle is going to be. Okay, so this is what happens on the graph, and this is why we can graph it. This is the cosine graph, and along the x-axis here are the angles in degrees, and up the side here, this is the relationship between the two chosen lengths, which in this case are the adjacent and the hypotenuse. Okay, so when you do 13 divided by 21, that hits us back with a decimal, and essentially what happens is you look up that decimal number, let's say it was 0.9 for instance, or 0.8 just to make this nice, and then you come across here and the graph tells us that for that value, when you do the division of 13/21, although it's not 0.9, there is a specific angle for all triangles that when you do this division you get the same decimal, because the ratio of the lengths are in the same proportion, you get the same angle. Okay, so because we have that, this is what the calculator is doing. It's saying, oh, okay, so you've got a triangle that's got adjacent 13 and hypotenuse 21, and when you divide them you've got a decimal. I'll look that decimal up and I'll tell you the angle that should be between those two lengths. Okay, so if we go to our calculator, this is what we've probably been shown how to do. So you press shift cos. Now that's because we want the inverse function. Whenever you move from a y-axis to an x-axis, you're using the inverse function And the same is true here. So whilst we've made the statement of cos x equals 13 over 21, to actually find the value of x, we want to use the inverse from y back to x. So I know that there are two lengths on this triangle that are in the proportion of 13 to 21. And if I hit equals, the calculator's going to go, okay, on the cosine graph, I'll do 13 divided by 21, look that up, hit the graph, come down, I'll tell you what angle is associated with any triangle whose adjacent and hypotenuse, their lengths are in the same proportion. And the answer is 51.75. And as an example, I could do shift cos of 26 divided by 42. Ooh. And of course, there you go, 51.75 again now. So that's our answer, x equals 51.75. Now, of course, understanding all this doesn't necessarily make you any better at finding the answer, but in the long run, when you ask to use the graphs and find multiple solutions to some of these trig questions when it gets up to grade 8 and 9, hopefully now you have a better understanding that in fact all you're doing is using a graph telling the calculator some information, and it's just telling you what angle goes with any particular decimal. Okay, so I'm just going to jump here to this question, which I think is on the next set of questions here. So what's happening again? So we'll go through our labelling process. This is opposite, because it's literally opposite the angle. This is my adjacent. So from SOHCAHTOA, that's asking me to look up the relationship between the adjacent and the opposite, and that relationship is recorded on what we call the tangent graph. So we say the tangent of the angle y, that angle will be found by asking what is the proportion of the opposite O divided by the adjacent A. Okay, so O divided by A. So just going to pause really quickly. Okay, so what would we do? Well, just in terms of a process, we would do inverse tan of 31 over 45 to get our answer. So we always do this process whenever finding an angle, because you're using the graphs, and I'll show you the graph in a minute, from the y-axis to the x-axis, from the decimal to the angle, we're using an inverse function. So then shift tan of 31 over 45. And we are going to get the angle of 34.6, let's say. So for all intents and purposes, there's your answer. What have we actually done though? So I've done 31 over 45, that's that decimal there, 0.688, and I've drawn the tan graph, that's the one you can see in blue. Okay, and there's obviously a little bit more to it because this graph oscillates infinitely, comes back and keeps going, but the one we're interested in is this. So we've asked the calculator, okay, for a triangle of opposite 31 and adjacent 45, that's 0.689, it's rounded it, what angle is associated with that? And if we come down here, we can see, there it is there, so that's the x coordinate, 34, so the angle would be 34.563, which is what we got on our calculator as well. So that is what the calculator is doing, it's having a look at the graph, having a look at the relationship, and then it's saying what angle goes with that. Okay, so that's kind of the intro. I think an important one. I'm not sure how many people have watched it, because of course you probably know how to do it, but nonetheless, when we move forward to trig graphs now, that should give you a good head start on that. So for the rest of the videos now, I'm just going to go through and show what we should have done to get the answers.